We are going to simplify this rational expression using the method in which we find the LCD of the numerator and the LCD of the denominator separately. So first of all, looking at the numerator, I have y and 5 both in my denominators, and so my LCD of the numerator is going to be 5y. Next, looking at the denominator, I can see that the only denominator in the whole denominator of this complex rational expression is xy, and therefore xy is going to be the LCD of my denominator. I'm going to start by getting each expression here over a common denominator on its side of the rational expression. So starting with 3x over y, my goal is a denominator of 5y for both of these expressions in the numerator, so this denominator is missing a factor of 5. So I will multiply this first rational term by 5 over 5. The next term is minus 1/5, and that denominator is missing a factor of y, so I will multiply it by y over y to get its denominator to 5y. Focusing now on the denominator, my first term is 2y over 1, and I want both of these terms to have a denominator of xy. Since this has just 1 in the denominator, I need both factors, x and y, to be brought in. And my last term, minus 3 over xy, I need this to have a denominator of xy, which it already does, so I don't need to modify that rational term at all. In the next step, I'm just going to combine each of these pieces so that I can see the common denominator clearly. That first one, 3x times 5, is going to be 15x over 5y. Second term is going to be just minus y over 5y. In the denominator, I'm now going to combine these and leave that second rational expression alone. 2y times xy gives me 2x y squared, since I have two factors of y being multiplied. And this is over xy. And that last term, minus 3 over xy, stays the same. I'm now ready to take it to the next step, for which I'm going to bring this arrow all the way down. My next step is to go ahead and combine over a common denominator both of these terms in the numerator. 15x and minus y are not like terms, so all I can do is write that as 15x minus y over 5y. And now the main fraction bar here, separating the numerator from the denominator of the overall expression. In the denominator, I have a common denominator of xy, so this becomes 2xy squared minus 3, also over xy. At this stage, I now have a quotient of rational expressions, so I can treat this main fraction bar as a division operator, meaning that I will flip over the expression that we are dividing by and change this division to multiplication. This will all happen in one step. So that my next step is 15x minus y over 5y times xy over 2x squared, that's 2xy squared minus 3. I now check for common factors, and since these two binomials can't be factored at all, they do not cancel with anything. They would have to cancel all or nothing. The only thing that does cancel is I have a factor of y in the numerator and a factor of y in the denominator. And these are monomial factors, so they do cancel. And I am left with just x times 15x minus y in the numerator and 5 times 2xy squared minus 3 in the denominator. We can multiply this out if we wish. It isn't totally necessary. It's okay to leave things in factored form, but if we wanted to multiply this out, we could also get the answer 15x squared minus xy over 10xy squared minus 15.